Hi everyone, welcome to the fourth balenaHub Meetup. If you haven't met me, I'm Lizzie, I work at Balena. And today we have a couple of our fleet owners who run citizen science projects in the hub. We really like seeing these citizen science projects. Obviously, we built the hub off the feedback we got from the Rosetta project, the Fold for COVID project, and we had a pretty much, overwhelming by our, expectations of what was going to happen response to that, with people wanting to join in and volunteer their devices for good causes. So we really enjoy seeing other people coming up with really cool projects that you can volunteer your devices to join in and do some good in the world. So you're not here to listen to me, so I'll hand straight over. We've got Arran, who you might recognize from the forums as Magee, who's talking about his fleet learners block. And I'm pointing but realizing that you're probably not in the same place as I am, so it doesn't mean anything. And then Keenan, one of the balena ambassadors, who is the owner of the Ribbon Network. So Aaron's gonna take it away. So I'll hand straight over to you.
Great, thank you. So I feel like if I need an introduction that says you may know me from the forums, then I've spent too long on the forums before. I now work with Balena, but beforehand, I think I spent more time on the forums than I do now. But yeah, so I'm Maggie on the forums. I have quite a unusual background to my path that got me here. My speciality or my field of expertise is actually in the humanitarian field. I've worked for the last 15 years or so on conflicts and emergencies and looking at response mechanisms to mostly education in refugee crises. So I've worked a lot in Syria and Bangladesh and Afghanistan, barely spent more than 3 months in one place at a time, bouncing around doing all this fun work. And tech has been the thread that has sort of run through it throughout. So when COVID hit and education suddenly moved into tech rather than tech moving into education, everyone was out of school. Everyone had to use tech to reach school, to reach learning for a significant period of time. The education technology field just exploded. It all arrived at once. And it exploded in a way that placed a number of different big actors at the center. Microsoft, Vodafone, these big names were coming in and trying to implement these education solutions. And I had this frustration that some of the disruption components that we talk about in technology, this idea of doing things open, this idea of doing things different, was being lost because of the rate we were having to move at. So being the radical that I am, or I like to believe I am, I thought, okay, I can have a go at doing this myself and put something together, open source, put something together that can be shown how this can be done without the large resources and control of big organizations and big companies, and be more relevant to the populations that we're serving, because I'd had tech and education as my thread for so many decades. So I came up with this idea of the learner's block. I'm going to start the screen share just because it's more interesting to look at an unmoving page than it is to look at my face. Anything's a step up. So let me find my screen share here. So I came up with the this idea of the learner's block. This is an indication you see of how many windows people have open on their screen at any particular time. You can tell by how long it takes them to find the page that they're looking for. So the learner's block had a couple of key criteria it needed to fulfill. One is it needed to be incredibly stable in very unstable environments. You know, the example of the refugee camp was where it was first rolled out. And we're not talking about power issues, we're talking about large periods of the day with no power whatsoever. And when the power is on, it's usually generated by solar panels. It had to run on incredibly low resources. because the solar panels that we were using at the small individual device level, as well as at a camp level, were just not powerful enough to maintain the type of current that we needed, particularly with the Raspberry Pis, which tend to be a little sensitive to current. If you've not got the right power adapters before you've bought a cheap power supply, you'll know all about this. It had to be able to be deployed and cheap, because we're working in a charity and NGO sector which didn't have huge resources, and it had to be accessible to not just people who were potentially tech illiterate, but illiterate completely. We're talking about those who have not really had any schooling or have had large periods out of school. So this is the interface of the block. Now, obviously, I can't connect to the block via Wi-Fi because I'd lose you all as I disconnected and reconnected. So instead, I've just given a little caption here of the captive portal. So you have this block, you connect up to it. The first thing you see is this little welcome to the learner's block and the ability to sort of capture the URL you need to access the device. And then when you get into the device, the goal of it, the principle was to have it as open and easy accessible as possible. And I see these two different interpretations of what open source is. There's open source in terms of the license, and there's open source in terms of how easy it is for someone to go in and actually use it for other purposes. And I wanted to achieve both. So the code and the interface designed to be as easily accessible as possible. On the front, you have a file browser, and the file browser works just by a very similar or familiar interface as you'd find on your computer, because if it's familiar to what people have used before, then the learning curve isn't as steep. And it allows you to do all your basic functions and upload and put content onto your device. This can obviously work from a phone, so you can have content on your phone that you bring into the camp, what you've downloaded before you get there. You connect to your device and you upload the content into the file manager. So the idea is then people can access this content just like anything else, and anything is there. It's not confined to any particular resource or type of learning content. It has a library I'll come back to, and a website. You can upload the content here in a website folder, and it will allow you to see your own custom website. So many countries, Jordan, for example, had developed their own online platform for learning and for EdTech. Best way to get it offline was to take what they'd already made, put it on a device that made it accessible. Obviously, it needs to be multilingual. So we've got a whole bunch of languages here, all contributed by Weblate, which is an open source platform where people I've never met and have no idea who I am have come along and contributed all these languages. Arabic, of course, with right to left, has to switch, the CSS has to be built to switch to the other side so you can read in other directions. A control panel with a login. So if you're not using the file manager, it's clutter. No one needs to see it, it's confusing. So we can disable the file manager and we just have the components that the user, the learner needs to see. Control panel passwords and Wi-Fi passwords. Obviously, we need to be able to connect the device to larger networks to be able to download content. The library, when online, allows you to see a list of pre-built resources, which is on a backend by Directus, another open source platform. And all of the content can be downloaded. I'm not going to leave that running because my internet's not very good and I may lose you. You can download things directly to the device. And then as you come back again, you can find it in the library. And then, of course, uploading the website content as well. I wanted to go a step further, so then introduce an application store. And this is bringing EdTech, free open source EdTech applications that are available into one place. So I wasn't competing. I wasn't in this idea of the capitalist free market. I want to promote my product idea. I wanted to work with everyone and let everyone's product become to the fore and not just promote my own. So these are all free EdTech apps that you can install. It downloads it and installs it onto the device. And then when you get to your front page, you'll see your list of applications that are available then to open. So this is all done, and I'll go through some of the tech details. This is all done, of course, on the Balena platform, just by connecting through the socket into the Balena engine, putting a Docker container that controls the app, and then just makes it available through an interface. And then finally, advanced, you can set your start page rather than adding more clutter to a user they don't need to see. Whatever you're using, if it's just the library, let's have them start on the library as the first page, not the home page. Or the application store, you can specify which application you want them to see first. So you only show them the features that you need. And then there's some basic functionality and system maintenance and so forth. Obviously, all this needs to be used in mobile. So when you render it, you can see the mobile friendly views, because the idea was to distribute low cost phone tech rather than laptops or expensive technologies. And come back to the beginning. And we'll do it for as low a cost entry point as possible, not just for my budget, but to prove a point that this can be done. So when I had this criteria that it needed to be stable, it needed to be reliable, it needed to work in low resources, I wanted easy update, I came across the Balena platform, which ticked all these boxes. It allowed me to use multiple hardware, allowed me to deploy all these different features. And as I mentioned here, allows me to connect and install other Docker containers with applications that provides them access to a wider range of content. I wanted to go a step further. So the App Store is actually a GitHub repository with GitHub Actions in it. So the GitHub Actions will run and it will pull the code from the Bookstack repository, build a container and publish the container. And then all of this App Store is built on a free application store backend. So there's no cost involved in it either. The only thing I paid for is the headless backend for the library with the content in it. So this is the project that's came out of bringing together tech and education, bringing together a little bit of rebellious, I don't like big companies sweeping in and taking our children's education frustrations that emerge from working in my sector in emergencies and conflict for a long time, and has led to me now working for Balena, which has laid out these wonderful next steps for me of what this will become. The idea is to now create this in a way that anyone can build the same interface and other interfaces with all these quick drop-in components interact with Balena devices. So we're looking at a local UI or a local UI builder, which will allow specifying a file, most likely a YAML file that will sit at the bottom of the repository. And people will be able to put in their own logos, own themes and colors. Everything will be open to however you want it to look. But you'll be able to bring in components that allow connecting to the engine and can be dropped in and install anything you need it to install. That will allow the interface to be configured all through one place, and will also create a base for us to produce more products to put out for people to use. That will then, of course, link back, and Balena's little contribution to social products is that product that we're building now together will then be the base of the next version of the learner's block, and we'll deploy it into the refugee camps and into emergencies and into Syria and Bangladesh and all these other countries, and allow people to hopefully continue using it. I should highlight, I've made a very pretty picture that everything just works brilliant, right? Tech is easy. A couple of challenges along the way. There were some security concerns among some UN organizations that have used it around the fleet, open fleet exposure. When there's maps of where devices are located, that created some challenges for us in Syria, where there was a number of targeted schools at one point, and organizations in country were concerned that it would give away too accurate a position. And because of the political and the complexities of the conflict, there was a whole different types of problems that we had to negotiate around that. So many of the devices actually run off the fleet. That was a bit of a challenge. And then, of course, there's the fact that it's very MVP. If you look too much behind the code, you'll find that it looks nice on the front and it does the job, but there's a lot more work to go on getting things tight behind the scenes. So I think I'll wrap up there. Fire any questions, of course, on the chat or at me whenever Lizzie here thinks it's the best time to take comments. And yeah, I'll be happy to answer them.
Thank you. That was really interesting, really fantastic to see it all working, because I'd known about the block and read the sort of description, but not seen it all functioning. I think it'd be interesting to know how anyone could get involved. Obviously, you've got some really big partners running this in some conflict zones and refugee camps and stuff, but it's available for anyone to get involved in. And would you like people to contribute and to join the fleet?
Absolutely. Some of the challenges are, of course, getting contributions, but more so is getting people to test it. This was something that we really wanted to use quickly because it emerged at the beginning of COVID, but it was used in a context where we didn't get second chances to put things right. So we really need people to be installing this and using it for wherever it may be. If it's not for education resources, but you have a purpose for a file manager on a small device that can host files, it will work for that too. You've seen the components there, you see how it can be configured. And then just feedback what works and what doesn't, what's easy to use and not, because I really need to get that stuff honed in the safer space that we live in, so that when it goes into the spaces that aren't so safe, it's as ready as it can be. So learnersblock.org is the website, and of course you can find it on the balenaHub as well, and links from there into the GitHub repository, and everything's there. Reuse it as much as you like. It's all MIT licensed. And yeah, just get in touch and tell me what you think. That's what I need most.
Cool. And we'll open up for questions from the group if anybody has any questions for Arran. Sometimes it takes a few seconds for someone to be brave and put their hand up first, but we can always take questions at the end if anyone has any later on. Oh, there's a raised hand.
I don't know who Jay Wingard is also, but they came off mute, so I don't know if they had a question. I think they were first, if they want to go.
There's a lot of pressure on this person now. If maybe you didn't, but they put you on the spot.
Okay, if not.
Not hear me.
Oh, there we go. We hear you.
Oh, great. Yeah, sorry, it took me a while to find the raise hand thing.
It's all right.
I guess I'd just love to hear more examples. Like, do you, I don't know, give us your favorite use case, or if there's something else coming online soon that you're excited about. I'm trawling the website now. I'm wanting to understand a bit more about some of how it's getting used.
Yeah, great question. There's how it's being used and how I'm hoping it will be used, and some things I may have done differently now in hindsight. How it's being used, it was targeted at education technology. As I say, EdTech was at the beginning of COVID and my field, and the beginning of COVID was the thing that was really booming. So there was an organization in Zaatari camp, which is a refugee camp in Jordan, where I'd been living at the time, and an NGO there who had these 2 boxes of Raspberry Pi 3s and not really any idea what to do with them. They'd been donated and they weren't quite sure how to put them into practice. And of course, this is something we've all probably experienced or come across people that have experienced. And one of the things that Balena tries to bridge, right? Opening up this ability to make things more accessible. So I wanted to do that for education and add that language to it. So the first thing was to just create the device, create something for the device that allows people to see it work. Okay, I can now start to come up with ideas on what I want to use it for, rather than me prescribing them. And I say that like it was simple. Actually, I started by building curriculum content and realized it was too prescriptive and created a lot of workload for people who were volunteering. So we ended up actually just opening up for people to pull on what they wanted and build their own content. So this NGO put on a content made by the UN, which was these grade 1 to 10 textbooks that were developed for the Syrian refugee crisis. Now, it's a very complex context, and I can't use up all this time on the call, but because of the way the conflict is divided, those sort of in Damascus and down that are controlled by the Syrian government will study in one particular curriculum and content, and those on the far west will be in another, and those in the far east will be in another again. So you have these variable content, and the UN had created this stuff that's supposed to go across all 3, but was too politically controversial. And then they started learning Russian in the Syrian controlled areas because Russia was a huge funder of the conflict. So they wanted to have a sort of say in this curriculum, because education and curriculums can sort of set political agendas. So it got very complicated and very political. So we opened up the content, and they put on this UN-based curriculum and brought it into IDP camps, which is internally displaced, and there was no internet and it was only intermittent electricity. And they took in a load of phones to go with it and allowed people to connect and download the content onto their phone. So there's an example there of how it was used in Syria. What I would do differently is I would call it a knowledge block, because the World Food Programme then said, we want to distribute some PDFs which talk about how to access certain food. And then the health organization said, we want to get information about WASH, which is, WASH facilities, toilets and latrines and things like this. And we want to distribute PDFs on it. And I was perhaps too narrow on the name after I broadened the scope of the product. So it's complex. I hope some of that answers the question on use case.
Yeah, that's great. Thanks.
More questions?
Oh, I was going to ask one about, you mentioned a little bit about it being a really low power constraint was one of the constraints you sort of focused on. And like, how did you think about that problem? Because I think that's like a challenge that a lot of people are facing right now with any embedded Linux platform, is how to like really get that to be like a super low power thing.
Yeah, I mean, we initially started with solar panels that tried to power the devices directly, obviously not completely directly, but for each individual device. But it was just too intermittent, even for those who were very patient. It was very optimistic in the first place. There was a small battery that sat on top that allowed for an element of power to be stored and distributed, but we spent so much time moving things around to try and get the power right. It just didn't really work. So then we moved to a larger battery system using the Anchor battery packs, which are just things you can find on Amazon. Again, we really wanted these easy supply chains, hardware and things that could be bought anywhere. So we weren't buying it in Europe and shipping it, which created overhead. We wanted them to be able to ship it directly into the context they were in. So we plugged them in these Anchor batteries, and they actually worked really well. You've got to make sure you've got enough amp output on there. It's a significant enough battery pack. They worked really well. But then we were plugging them in to the mains and running the device on it. So it kind of acted like a UPS, like a alternative power supply. Turns out they're not configured for that, and they died because they were draining and recharging all the time rather than sitting idling. So we ended up losing a whole bunch of battery packs, not understanding how the Anchor battery packs worked. Ultimately, we ended up trying to connect to the grid in the refugee camps, which is worth a Google. They have these huge solar panel arrays that run across the outsides of the camps. The power is still intermittent, but the people in the context have just kind of got used to having outages, unfortunately. So we haven't really got a perfect solution to that, but that's kind of as far as we got. A lot of the stuff you find on the website on power and things was just built into the Balena platform, right? We wanted the low energy, the low resource. Most of the advertising, sort of what does this device do, is pulled off the Balena page and put on mine because it came packaged in there. Delta updates, which to talk about so proudly, someone else had already done that. The same kind of applies to power. I wish I had some breakthroughs, like all the bullets, I could say, oh, this works, but no, we're still struggling with that.
One of our new staff members, you might not have seen, but he's developed a balena block. Mostly confuse it with a learner's block, which is not a block, on balenaHub. He's just created a balena block which puts Raspberry Pis into deep sleep and low power mode, so they use sort of minimum energy, minimum resources until they're kind of woken up again and used. So if it's not a consistently used project, then maybe we can get that block on it as well, which could be cool, although it might require a little bit of extra hardware, which might be difficult in your specific use case.
Yeah, one of the most difficult things about it, I think, is like building anything, is knowing when to stop building.
Yeah,
always more that we could add and more features and make it more advanced. And although that looks good from our chair, from the user's chair, it doesn't. It usually adds minor gain for quite significant complication. And we wanted to just try and keep as low key as possible, as simple as possible and stable as possible. And the rest we can figure out rather than try and get to to advance and release constant updates and things because the context just didn't allow it. So I'd love to do that, but it would need so long to test and try it out, to make sure that it's ready to go. It was quite nerve-wracking the first time we put them out because they were going a long way and they weren't easy to get back and they weren't easy to get to. There was a lot of sleepless nights before they went to the first camp because I knew that once they'd gone, I couldn't just connect them to a fleet and push an update. That was it. And there's people sitting there with these useless devices and it was intense. But yeah, I think we got the balance right for now.
Any more questions, or should we hold them to the end? I think we'll move on, and thank you very much for demonstrating that. It was really, really interesting. We'll move on, and Keenan can tell us all about the Ribbit Network.
Perfect. Hello, everyone. I'll share some slides, though you all can feel free to interrupt me and deviate from this. I'll put the link in the chat just now to the slides as well, if you prefer to follow along on your own. And let me share my screen. Yeah, super interesting to hear about your project. Maggie, I think I've only seen you on the forums before, so it's cool to meet you in person, and that's super cool. Yeah, my name's Keenan. I'm here to talk about a different project called Ribbit Network, obviously built on Balena for a super different mission in Citizen Scientist. And our mission is to build a missing map of where does CO2 emissions, and then perhaps more broadly in the future, just all greenhouse gas emissions, where did they come from through this network of open sourced, crowdsourced sensors? So briefly, just to describe the problem of climate change, which perhaps you're aware, perhaps you're not so aware. It's we have this large problem with climate change that causes all these kind of crazy bad effects. And the really interesting thing about it is we know there's a lot of debate about what the bad effects are. But actually, we know exactly what's causing it. It's greenhouse gases. It's super clear. There's no debate about what is causing the problem. It's greenhouse gases, and specifically, we know in order what greenhouse gases are the worst, and carbon dioxide is sort of the most effective in terms of the output. And it's this chart is now a few years old, and it's even more shocking if you look at the recent ones. But it's oh yeah, humans have started producing greenhouse gases at an egregious rate that's really increasing the number of greenhouse gases in the planet, and that causes all kinds of badness. And so when you think about that as a scientist, you put your scientist hat on, right? You're okay, great, we know exactly what's causing the problem. Let's go fix that. We need to make this graph right here go down. That's the goal. It's actually super easy. The problem is that we we have a really clear idea about that graph, the global scale, which is super important and useful. But when we talk about how we deploy solutions, we don't deploy solutions for any problem really on a global macro scale all at once. That's not how change in the world happens. We see change happen at the very micro level, in your town or in your city, and kind of in aggregate, all that stuff really adds up to be a global kind of solution. And so we don't really have any sense for let's say that your city, this is an example map. We don't have this map for your city or any city in the world about okay, what's the relative scale of where emissions come from? How do we think about them? How do we think about, if you're a city council member or you're voting, for example, in the United States or wherever you live on a particular measure about climate that's probably hyper local, you don't really have good information right now on how to make those decisions. It's all based on this really awesome and heroic effort of estimation that's done with this crazy series of spreadsheets and trying to correlate information that's correlated to emissions, we think, which is probably inaccurate. And so great, I think there's a real solution here just in direct measurement, and it's been really validated in scientific labs. So like I linked to one of the papers here. There's a few research labs that have done this. They said like, okay, yes, we've deployed sensing in both Berlin and then in Berkeley, California. And we know that this works. And so the challenge now is like, great, let's take the academic work over here and move this into the real world of scale. And that was sort of the problem statement that I started with. And I founded Rip Network just as kind of like an interesting passion project for me as somebody who is working in climate, but it's really grown into something much, much more than that. And now we have an official 501c3 nonprofit, which is the nonprofit organization designation in the United States, which is really awesome because it lets us work in the open source and sort of build a real organization around this project. And we've got a couple things that we do. The first one is we build the sensors because we have to have these sensors to go out in the world. We call them our little frog sensors, and I have one here as well, so you can see it. And I'll talk a little bit more about what makes up a frog for this group, because I think that probably we're a little bit technical here in this audience, which is great, so we can get into some of the technology there. These sensors, super simple. They go out and they are an open source sensor that measures today CO2 in the atmosphere. And so if you can imagine, if we put enough of these sensors around in the world, we can build this relative heat map of where do greenhouse gas emissions come from. And sort of the design goal is like, let's make this thing so low cost that it's possible to blanket a city like this and really start to like get this awesome data set, which we need for science. Just one note here, I think this is a good time to interject about the name. I chose Rivet Network, one, because it's fun. Like frogs are fun. It's a nature-based theme. Everybody knows what a frog is, pretty much depending on, you know, whatever socioeconomic status you have, no matter where in the world you are, you probably know what a frog is. So it's a great mascot for the thing. They're also a sort of our best indicator species for climate change. So frogs are super temperature sensitive. You know, they're cold-blooded, they live in the water, so they're very affected by temperature of climate. And they're probably the species that's most at risk today in the macro sense for climate change. They're kind of a great mascot for this project. They also like create a sensor network, just like our IoT sensors, right? They ribbit to each other, making the little sound and create this really dense informational network in nature, which is very similar to how our sensors will talk. So I think it's a cool mascot. Of course, the most like interesting to me impact part is like all these sensors are generating data, right? So we got to put that data somewhere and host it so it's useful for people. And I can show, you know, sort of our live website right now. So we've got this awesome website where you can zoom around, click on different sensors, you know, see their data here. That one is offline, but we can look at a different one and see, you know, the CO2 from that sensor and all of our other measurements like barometric pressure, humidity, temperature. And we're just sort of growing. So like we're mostly in the US right now, but we do have one sensor kind of hanging out here in New Zealand, and we've got a few popping up all over the world. Yeah, so that's our data. You know, right now, like I said, we're growing super fast, and I'm feeling like we have a lot of momentum behind the project. We were just one of the winners of the balenaHub challenge here. So now I've got this excellent placement on Etcher, which is a tool that probably everybody on this call is super familiar with. We now have over 100 people in our Discord channel that are super active and building this project together, which I'm so excited about. We've put together like a really awesome core team of people who are sort of the core volunteers that kind of make this work. Although there are, you know, certainly vastly more volunteers than this that contribute in smaller ways, and all of that's great. You know, one of the things that I wanted to do on this call is highlight that we are growing, and there's like so much more work to do that is not contained. Like I can no longer do most of it. So we're looking for other people who are interested in helping us out. You know, I've kind of highlighted some specific need areas that we have here. If one of these things sounds like you or sounds like something that you're interested in, you know, get in touch, find me on Discord or the Balena forums or email or whatever. We've got links in the website that you can get a hold of us, and we would love to hear from you. Kind of where we're going, right? So this slide's a little bit old from earlier in the month, but right now our goal is to build this really awesome active community. I think that's kind of the key to any project like this, is building a really vibrant key community around it. The technology doesn't exist in isolation. Even though we are a technology project, the technology will sit on the internet forever and die if there's not a good community around it. So that's really our focus today. We want to have a lot of people building their own sensors, contributing to the design, making it better, making sure it's good. There are definitely flaws in the sensor that we have right now, and that's one of the reasons why we're looking for some people to kind of help improve that sensor, and so that's kind of our next milestone. Hopefully in the near future after that, we'll do a crowdfunding push to do sort of maybe a larger manufacturing run of frog sensors. Because most of them have just been built by individuals or me personally in my house here, which is great, but not super scalable. Get to frogs over the world. And then, the ultimate goal, I put this impact bullet here in the top right at the end, like that's where we want to get to, right? We want to have people using this data to create impact in their local communities. And that's the real goal. We're working together all on GitHub and Discord. So we've got a great GitHub project, which is collating like all the stuff that people are doing collected by project. I encourage you to check it out if you're interested and jump in with things that maybe you have thoughts on or, interest in. Yeah, so that's kind of like the broad strokes of the project. I was just checking the chat to make sure we didn't have any questions. Mark says he'll turn his sensor back on tomorrow, which is great. Please do. Talking through the hardware a little bit, this is, so I think the block diagram is close to correct. These are kind of old slides. The pictures are not, but I brought this other frog here that we can all look at, hopefully. So from the hardware perspective, it's pretty simple. We've got like a Linux single board computer in here, along with some Wi-Fi antennas. Today we've alternated back and forth between a Raspberry Pi Compute Module 4 and a BeagleBone Green gateway, depending on what the supply chain circumstances are at the moment, which are quite challenging, I'm sure, as all of you know on the call. And right now, actually, we're in the tough scenario where you can't buy either of them on any of the major manufacturers in the world. And so I have luckily a stock of some Raspberry Pis that I bought from Raspberry Pi Foundation directly at the beginning of the year, but we're not really sure where to go after that point because we need sort of long range antennas. So the Raspberry Pi 4 is not good enough. So we're in the midst of that design cycle right now to figure out what the next step is for us. But on top of the frog, if you take off the head here, and sorry if my camera keeps blurring it, that's where the good stuff is. This is where the sensors are. So we have a barometer, we have a GPS sensor, and then we've got our CO2 sensor, which collects all the super interesting data. And they live inside of this little screen, which if you can see up in here, and sorry, my camera keeps blurring it. It's like it's open, right? So that we allow good airflow. But this screen design keeps the solar radiation off of the sensors, keeps rain and water and stuff out, but still lets you have good air exchange with the environment outside. Yeah, that's just some old sensors. All of that connects, into our web database. So we've got a bunch of frogs over here on the left. Those are all publishing their data to InfluxDB, which is our cloud provider that we use. And then we render that with a technology called Dash, which is sort of like a Flask Python app with a bunch of UI libraries all packaged together nicely that generates that website that you see. This is something that we also have like a lot of improvement to do. Like we want to put a proper API in here about exchanging the data in and out of the network. And that's also work that's in progress if that's something that's super interesting to you. In terms of Balena, since this is the balenaHub network, we power the whole fleet off of Balena. It's great. The open fleet concept was really like, I think coming into existence right around the same time I was starting Ribbit Network. And it was just such a natural, like awesome fit for exactly this project, because we want people to be able to build their own sensor and connect it into the fleet easily. And that's super difficult to do today on any other platform than Balena. It's like really like there is no other option that doesn't involve you writing like a lot of software to enable that to happen. So it's really been like a critical enabler for a Ribbit network. So we run our software there. We've got a few different like Docker images and things which all help us power the project, all of which are, still very much under development, and we're looking for people to help us improve them. We've got like our CO2 Docker image, which is responsible for all of the like gas sensing and like getting that critical data. We have a GPS Docker image, which handles connecting to different kinds of GPS sensors. So we support a few, and connecting to GPS and like parsing the information is not necessarily trivial, depending on all the kinds of modules that you might have. And then we have the awesome but infamous in the Balena community Wi-Fi Connect project, which allows you to connect your device to your local Wi-Fi network some of the time. And hopefully, we'd really like to see that improve. And that's like an area that we're always looking for people to help out as well. It's like, I'm joking about it. It's like an 85% good solution, but it is probably the number one pain point of our current product today. Yeah, I thought it would be cool just to reflect for a few minutes about some hard and easy things I've learned in the project. So like unexpectedly hard things is always fun. The supply chain issues that if you're working in electronics in the last, I don't know, 3 years, 2 years, however long it's been, have been incredibly difficult to get your hands on any hardware, which, maybe 3 or 4 years ago was just assumed to be available all the time for you. That's been super challenging for us, especially as, kind of like a hobbyist open source project. We don't have a lot of like purchasing power to do like bulk purchases, for example, of things. And so it's been really difficult trying to pivot our design constantly around the evolving supply chain situation. Since this is a client project, we really thought that it would be super easy to do like a solar powered sensor in the very beginning, but it's turned out to be so much harder than we thought. Like there is no real good solution today, especially one that can work in an open source sort of collaborative environment that we really value, that will allow you to do that. We can't get the power of any of our Linux boards down low enough without building a lot of custom electronics around it to do a solar powered frog that doesn't require like massive solar panels, for example, that'll blow up the cost of the unit. And by the same token, there's no sort of like fleet management that works with a microcontroller based solution. So basically, like running the balenaHub workflow on like an ESP32, for example, we haven't figured out like what the right technical way to go is there. We love Balena and I am fighting as hard as we can to stay on it, but figuring out how to do that in a solar powered way is proving to be quite challenging. Another thing that was surprisingly difficult, which I assumed was easy, is like a quality like Wi-Fi module that goes on a Linux board. It is surprisingly difficult to find that, and especially one with a supply chain that makes sense. That's why we've stuck with the Raspberry Pi CM4 and the BeagleBone Green Gateway, is because they both have integrated Wi-Fi modules that have external antennas. So good high gain antennas that can get us the range that we need. The range and reliability of any of the USB based Wi-Fi modules is super bad. And it's really quite poor from a packaging perspective mechanically. If you think about like, how do you put together a product that works with one of those things that has to go outside? It's like nearly impossible to do it. And I just assumed that was a solved problem, which it is not, as I've learned very much so in this project. Expectedly hard things. Funding, of course, is expectedly hard. Trying to put together funding to make a project like this work is hard, no matter how you do it, whether it's for profit, nonprofit, doesn't matter. It's just a hard thing to do. I've been super happy with our choice of nonprofit to go with it, just because it lets me work in the way that I want to work and focus on the impact rather than like some other distracting business goals. But it's still something that we're trying to figure out how to do. You know, like one of the questions that I think about a lot and often is like, do we need to have full-time staff or not in the future? Today we don't. Like, this is still a side project for me. Like, I have a day job to keep my bills paid. Like, I don't make any money off of Ribbit Network. But I see the scope of technical work that exists in front of us is quite large. And that's still an open question that I think about quite a lot. Unexpectedly easy things, which I think is the most fun bullet to hit, is it's been super great to just build a community around this project. Not that it wasn't a lot of work, but it's really come together like and blown me out of the water, like how many people have coalesced around the project. And we've got excellent contributors who are working with us all day, every day to put together what I think is hopefully a good, you know, even if we don't achieve the impact through the data of Ribbit Network, hopefully a good educational and experiential thing for the people that have been involved in Ribbit Network. So that's been super satisfying in its own right. Creating a 501c3 not-for-profit in the United States, also not trivial, but way easier than I thought. So if you are interested in that process and you maybe have like a similar open source kind of thing that you're thinking about, happy to talk to you and coach you through it if you'd like, because I think it's great. It's a really good container for like open source projects. And I think that is kind of the end of my slides. So I don't know if people have any questions or like what I can elaborate on further.
I just want to say thank you for the presentation. I've obviously heard a lot about the Ribbit Network in the last year, but every time I talk to you, I learn something new about it, which is really delightful. And yeah, makes it really interesting for me to listen to you as well. But yeah, I'll open the floor up for questions. Feel free to shout out or pop them in the chat. We've got a couple, I think, in the chat there.
Yeah, it looks like there's a question, what calculators you're using for CO2? I'm not sure I understand the question. I think the current state of the universe is that people are using calculators to calculate their CO2. We don't use calculators. We measure CO2 directly with a sensor.
Does the sensor just take care of it all for you? That's basically what it does.
Yeah, it's a CO2 sensor, so it directly measures the quantity of CO2 in a contained gas area.
Do you sum it at all? Like for like if you do you combine the sensors at all for
that's something that we will do once we kind of have sufficient network density to do it, right? Right now we're kind of at the phase where we're still deploying enough sensors to be able to make those aggregate measurement calls, but that is definitely something that we will do in the future.
Cool. It's a cool project.
Yeah, thank you. And it looks like Tammy has another question in the chat. Could you tell us more about the technical challenges of solar integration? I assumed I could just slap on a solar panel, but I guess it's more complicated than that. Yes, that is exactly my thought. I would say an average engineer that's a generalist at several things and not excellent at any of them. I assume that was the case also, because if you kind of go on like Adafruit or SparkFun, you know, you can kind of get all the components that you vaguely need to put together a solar powered project. And if you're interested in that kind of thing, I super encourage you to go do that because you're going to learn a ton. And one of the things that you'll learn very quickly is that the solar panels always underperform in the power ratings that you are looking at. The battery chargers don't necessarily work in an intuitive way, especially when you deal with how, you know, what happens if you deplete the battery. Can the system like turn itself back on enough to charge itself to be on again? And the same problems you have when you think about temperature. So a lot of the off-the-shelf battery chargers don't account for like low temperature, for example. It's like it's unsafe to run some kinds of batteries below 0 Celsius. And that's just not accounted for in a lot of the off-the-shelf products. And the foundational problem is that like any of the single board Linux computers, like the Raspberry Pi, for example, doesn't have a true sleep mode. So if you start doing the math, like what's the power consumption of this thing, you just can't make your power equations work to keep one of these things online persistently in a like average solar environment, I would say. And so if you look at the people who have built products around solar powered Linux things, they build a whole other host, basically a second compute system, which has like a microcontroller and all kinds of power electronics to turn the Raspberry Pi or whatever your single board computer is on and off. Totally disconnect it from power in a hard sense so that you can make the solar powered work. Yeah, there's a little bit of a suggestion about ditching Wi-Fi and going with a LoRaWAN project. Yes, that would be great. We just haven't, I think there's not an easy technical path to do the over-there updates in that way yet. So that's certainly an area we're exploring. And if that's something that you're interested in, I definitely encourage you to come join us and help us chart that path. Any other questions or anything from folks?
I think we have a raised hand.
Oh, hello. Yes.
Yeah, hey. I don't think I anticipated quite how much overlap there'd be and how many questions I had. I think the first question should be that we should certainly make sure we continue this, because we've shared a lot of similar experiences, and if nothing else, it will make for great therapy after we
yes,
gone through some of the traumas. And just to recognize then that the time you've put into this, I think you probably understated it. I know firsthand that this has probably cost you a lot of your time and commitment to it. So it's very impressive. My questions are multiple. I'm just going to pick one or two. One is hardware choice, both during the shortage that you touched on briefly, but before the chip shortage. How have you negotiated the hardware requirements versus the price entry point and tried to find that balance?
Yeah.
And the other question is on the microcontrollers, putting aside the fleet management side of it. Do they have the sort of processing power you need for the type of sensors and data that you're collecting?
Yeah, it's really interesting. I'll just address that one first. And yeah, I would love to continue the discussion. I know we've had some discourse about local user interfaces as well, which would be super cool for like Ribbit Network. And so yeah, let's definitely keep it going. But yeah, our compute requirements as of right now are not that complex, right? Basically, all we do is like get the data, push it off to the cloud. And it's been really interesting because like, most people, when they put together a product, they don't start with like, how do we do remote updates first? Like that's not a first line requirement of the product. But for me, I was like, hey, this thing is, we're going to build this and grow it. And it's pretty scrappy as an MVP right now. So I must have this like on day one for like the first sensor that we ship. And sort of just the only easy way to do that for me was through Balena. So that really like bucketed, like we're going to stick with single board and embedded Linux computers that can support Balena as the first choice. And then we down selected that further into say like, okay, well, which ones have a reasonably like good Wi-Fi antenna that we can use, since the sensors live outside your home or apartment. You kind of need a higher Wi-Fi range than a lot of things. And that really puts us down into like 2 or 3 options for like embedded Linux systems. Yeah, I don't know. That's kind of how we think about the hardware system. Certainly people are exploring other options in terms of like, okay, like could we do something more exotic with like, a LoRaWAN or Sigfox and things. And that sort of relates a little bit to the organizational challenges around like doing an effort like that requires writing a lot of software probably, and trying to figure out how to coordinate that with volunteers has been a little bit challenging so far. Not that we're not going to figure it out eventually, but we certainly haven't cracked it 100% yet. So.
And
yeah,
on the price point, you mentioned, I asked about the
Oh, yeah.
balancing the price point with the hardware, particularly the beagle bone selection?
Yeah. We've just tried to keep the price point as low as we can without sacrificing on the quality of the data, basically. So it moves around a little bit. We don't want to go over. Right now, our price point for the bomb, I think, is about $270 US. We would like it to never be above 300 US, and certainly as low as we can go without significantly compromising the experience or the quality of the data is sort of like the rough operating bucket that we have. I think a dream goal would be like, if we can get under 100, that would be rock star. That's super challenging to think about how to do that right now, especially, our cost is dominated by the sensor actually. And so there's a little bit of like a supply demand question of like, how do we get to a price point that low? Is something that is super interesting to think about, and we don't have a lot of answers yet. And then Jay Wingard, I think you have your hand up. I don't know if I'm saying your name correctly.
Yeah, no worries. I was wondering if you had any formal contacts to academia.
We do. So I've spoken with the PIs at a few of the labs and some of the papers that I mentioned. That being said, we're always looking for more. And I think that's one of the core member volunteers that I'm looking at is, somebody to kind of go help us do broader scientific outreach. So if that's something that you are interested in, or even if you just know leads of people to talk to, we super welcome that, because that's a key component to this project's success, obviously.
Yeah, and I think that would be a path to real funding. They might push you a little bit in terms of the sensor you're using to get something slightly higher quality, but because there's a lot of academic projects actually trying to monitor exactly this, and citizen science is definitely buzzy. It would get, I see most of your sensors at the moment are in the US. Well, the NSF would jump on that. They'd love it. The EPA would be interested. Like you could, but you need the data to be sufficiently high quality to get the scientists interested, and they're going to want calibration procedures and rigor around there. But I'm sure they would jump on this. Like a lot of citizen science projects have done some really amazing stuff.
Yeah, it's an interesting chicken and the egg problem, right? Like we kind of need some funding to validate the concept, but then we need the validated concept to get funding. And right now we're in that super bootstrappy part where it's like, which one is first, so that we can do all the rest.
Yeah, I can drop some links. I'm thinking NIST, National Institute for Standards in the US, actually does quite a lot of CO2 monitoring. USGS and USDA would probably be interested. USDA has a program that looks for engagement with schools. If you pitch this as a school project type thing, you could map the whole US if you just got a whole bunch of schools to do it. Or AmeriFlux is like the main database for CO2 capturing in the US.
Yeah,
it's all US centric, and you're looking global.
Totally.
But...
Yeah, and if you know particular contacts at those organizations, because we've done a fairly large outreach campaign, and like unfortunately, a lot of the responses we get back are like, "Oh, we're not working on that anymore." So like, if particular contacts are super helpful at any of those organizations.
Okay, sure.
Yeah, that would be great. Thank you so much.
If you want to, I can share some contact details or a way to get in touch with you in the email that I send with the recording and everything else. So
yeah, I'll just put my email again in the chat here.
Okay.
But of course, you can also fit anywhere else. So yeah, feel free to reach out.
Cool. Are there any other questions? I think we might have had one in the chat from Rose. Could you talk about the mapping a bit? And she's also asked you to share the Discord channel.
Oh, yes. The Discord link is on ribbitnetwork.org. So I will plug that, but I can find it here in a second. And then can I talk about the mapping a bit? I'm still sharing my screen, right? So you can see ribbitnetwork.org here.
Yep.
Yeah.
Okay, cool. if you click on this join the community button, that will get into Discord. And then the question was, can you talk about mapping a bit? Maybe could you expound on the question slightly? Like what genre of that mapping are you interested in?
Just how'd you decide on using Carto and OpenStreetMap? And did you build that part of it? And then do the devices each just have that? How do they connect to it?
Yeah, so let me go back to this diagram, which might be helpful a little bit. So the devices are all here, and so they're running inside of our balena open fleet here, right? And then what they do is they all publish data to InfluxDB, their cloud service, which has been awesome because we get to, so far we're running on the free tier of InfluxDB. Like I said, funding is definitely a challenge for us to host this data. And so we've tried to keep it as lean as possible. And InfluxDB is a good time series database to do that. And it's probably the most money efficient database service that we can use for time series data. And then the question is like, how do we render that data into something useful on the front end? And, kind of like I said, I'm an average generalist at several things and not an expert at any of them. So Dash is another open source project, which I will plug, that has I would say it's probably the easiest way to get to the MVP of like a website like this, that you can plug in OpenStreetMaps and render these graphs and do all these things that you'd like to do very easily. And that was just sort of like, it was the easiest way to do this. Yeah, I'm sure there might be a better front end kind of technical solution. And if that's something that you're interested or know a lot about, we would certainly welcome your expertise on that matter.
I'm just curious if you had made those as conscious choices, but it sounds like it came with Dash. And I'm just asking because my side project is making a tree map. So I'm just curious as to why you chose this.
Yeah, OpenStreetMap is the one that you'll see anybody who's trying to run a very cost efficient program use, because it is the cheapest mapping tiling service in that they have a free tier. You can't really use a lot of the other services for free, unfortunately. So you'll see that quite common. And it's very easy to plug that mapping component into these graphs. So like you can do cool things like zoom in on the graphs, for example, which is part of the Plotly libraries. And Dash is a project that packages Plotly as the JavaScript libraries. So it seems kind of like best in class for the graphing component, at least is my understanding.
Cool. Yeah, I've used Google Maps and Mapbox.
Yeah, I think unfortunately both of those just have tiered pricing structures.
They do, yeah.
For us, keeping it as lean as possible, so I'm not spending a ton of our money, which kind of relates to the funding question again, right? Is like certainly a goal.
So far for our tree map, their Mapbox is basically
and recorded, and your voice may be used for verification.
Oh, I don't know what that was.
Welcome to Chase, para español, oprima el asterisco.
I think someone is calling
Please enter
Chase.
your debit card, account number, or user ID, followed by the pound key.
I got the name Grace on the screen.
Yeah.
Grace, I think you're unmuted and you're streaming your phone call to us.
Charges, press 8. For other options, press 2.
I think the admin can use Grace, can you? I don't know.
Yeah, I was just figuring out if I can do that.
Two other questions from the chat while that gets sorted out. There's a question, are we using the Open Balena or balena.io? So we use the balena.io service, but because we're an open source project, we get to use it for free via the Open Fleet, which is what I said is like a critical enabler of Ribbit Network, which is excellent. So you can check out our, on the balenaHub, you can find Ribbit Network and find all the instructions to download our image and join the fleet and build your own sensor if you'd like. And then the other question.
Oh, sorry. I think, Arran, have you used Open Balena before for your projects, or is that something I made up?
Yeah, so I started with Open Balena before the cloud was available for free. So it was a wonderful access point, but obviously involved the maintenance of Open Balena myself, and the setup and things. So I shifted over to the cloud as soon as I could, because it also sort of increased the transparency and raised more awareness around the project. So yeah, both have proved fruitful. But I am quite glad to have whoever it is at Balena who's maintaining it for me now, rather than me having to manage my own services with Open Balena.
Yeah, definitely. And then the second question was, what kind of protocol do we use to upload data to InfluxDB? So we use, one of the benefits of running on Linux and running on Balena is we can use sort of easy to use programming languages, which makes it very accessible to people who are maybe on their learning journey as part of the project. And so we get to use the Python client for InfluxDB. So you can see like here where we pull it in. It's probably not the most technically optimal solution that there is, but it makes it very easy, which has also been kind of a design goal for us. So I sent a link to that file where you can check it out if you'd like. And can I give us more details about the hardware? Alex, I think we covered it a little bit. And if you check out the slides, I've got some good block diagrams of how the hardware works here. I would also encourage you to check out the Ribbit Network Frog Sensor GitHub, which has all the exact instructions on how to put together the hardware. It has the two major versions of the Frog that we've built so far. One based on the Raspberry Pi CM4, and the other based on, this is actually out of date, but it was the BeagleBone Green Gateway. But the BOM linked in here is correct.
We're just kind of spitballing a bit here, but it's so fascinating to see we've followed similar pathways. On the hardware thing, I noticed you've gone a similar way that I have recently, which is the CM4 on what looks like a WaveShare board.
Yeah.
Which has really reduced the price point for hardware for me, and provided a eMMC with the CM4 rather than SD cards, which is also a big sort of friction point and concern when you're running devices in your case in tough environmental conditions, but also for long periods that can't access them.
Yeah. And
then you also mentioned the antenna, and it's added the antenna. So just recently I looked at a price comparison, and I was looking at the WaveShare. You're slightly different than me. I got the WaveShare Nano B, which is the one that's the same size as the CM4, but it has a few less ports on it, which I'm not using, such as the Ethernet, because I'm using Wi-Fi, and it has less USB ports. So it took off things I didn't need, gave me eMMC. And I'm looking at about a Raspberry Pi 4 with an SD card at about $50, and the CM4 with the WaveShare board with the eMMC for $60. So for a small price increase, I managed to get quite a significant hardware boost.
Oh, cool.
I imagine the question is the reliability of the WaveShare board. They seem extremely well built, but really the bulk of the legwork is being done by the CM4 anyway. Really, it's just the carrier board that they're providing. So I sort of felt comfortable to roll the dice with these boards, and the supply is pretty good. So I noticed in your picture that you'd gone a similar pathway. So sort of pulling a bit.
Yeah, for sure. I think this is probably one of the best ways to go. I think the only thing that we're not super happy about the WaveShare boards is they don't have a good connector for our sensors. It's like getting a good connector for like the I2C lines for the connector is like not something that the WaveShare has. But hopefully there will be a board in mass production. Like I know the Pi Nora is an open source project that this guy named Timon just pushed out through Crowd Supply, which is an open source crowdfunding campaign. And that one is basically the same thing as these WaveShare boards, but it has that I2C connector, which makes it really reliable and easy to build. And we're just waiting for that to get into mass production before we can roll over to that.
For how well it comes across on screen, we'll actually have one of the boards here
cool.
that's more on the thing. What's also been surprisingly helpful is the size has taken me down from a Pi 4 quite significantly into a smaller unit,
Totally.
which has also been beneficial. Again, there's less ports. This one is actually the slightly more expensive one that allows me to connect it to a network. There's another one which is without this, but the lack of, or having less ports mean just not paying for things I didn't need. And SIM4 sits on the bottom. Downsides, I guess a little more technical challenge in flashing it. Of course, you don't just pop a SD card in. You can, but you ideally use a CM4. It's not particularly difficult for tech people, but maybe harder for build at home. And the case situation, you can't just go online and buy cases. You have to sort of make your own design and 3D print your own cases to find something that fits. But yeah, I've been happy with it so far.
Yeah, for sure. We haven't seen any reliability issues with the CM4 with the Waveshare product, so it does seem solid as far as we know, sitting outside for a while.
Except Wi-Fi. Wi-Fi is the one that will gets us all, and not just because of the software side. It's just a difficult needle to thread.
For sure. Yeah, it's a super hard technical problem that honestly, it's like a miracle of humanity that we've achieved a common standard for these things to all work in this way. And so, but it is certainly not a totally solved box of problems.
So there is the Python Wi-Fi Connect, which was my answer to the challenges you had with the Wi-Fi Connect. I was having exactly the same issues, and I ended up trying to modify it, adapt it, and wrap it in other fixes, and ended up just building something different in Python, which I found to be more reliable, more predictable. But I haven't moved boards quite as much as you have, which may create some challenges. But there's also the basis for one in Node. The Wi-Fi repeater has some code in it as well, which is a Node-based, JavaScript-based, TypeScript, I think it is, like TypeScript-based Wi-Fi Connect base that someone could build onto. But I think the fact that there's so many options just speaks to how challenging this is. none of us have quite cracked it yet.
Yeah, totally. Yeah, and that's actually an open task that I haven't had time to get around to yet, but I'm hoping somebody will pick it up, is to like try dropping in your Python Wi-Fi Connect into the Ribbit project and just make sure it works with the hardware set that we have. And so if anyone in this call wants to do that, please come over and we will help you.
I think on that note, maybe we'll wrap up because we've just gone a little bit over time, and you guys can keep the conversation going. Maybe another time, I'm sure we can share emails. But yeah, if anyone has any other questions, I've just popped a link to our forums in the chat, or like Keenan said, jump on his website, join the Discord, and say hello and keep asking questions. I'm sure he'd love to see you there. Yeah, thanks for coming, everyone. We're actually going to take a break next month with so many people on vacation in August, and pick back up again for the next meetup in September. So hopefully we'll see you all there, and I'll send around an email with the details on how to register for that. So yeah, if you see you all there, and if you have any feedback on these meetups in general, or what kind of topics you want to see, what projects you want us to invite on, or if you have a project on the hub you want to bring on and chat about, we'd love to hear from you. So feel free to get in touch with me. My email is just busy@balena. I'll pop it in the chat there for you as well. Yeah, thanks guys. Really great to have you on.
Thank you.
Yes, thanks for hosting.
Okay, no worries.